Hello guys. So today we are here to solve this problem, very interesting problem called find mode in binary search tree. So in this problem, we are given a binary search tree. And as we all know, a binary search tree is a special kind of binary tree. Binary tree is a tree which can have at most two child nodes. Any node can have at most two child nodes. In that tree, any node can have at most two child nodes. Either the left node can be there or the right node can be there, or one of them is missing, or both of them could be missing. But the number of child nodes of a given node in a binary tree is at most two. None of them could be there, one of them could be there, and both of them could be there. So, and the second thing is this mode. So what is this mode? Mode is the most frequently occurring element in the tree. So this element, by this element, they mean the value. So if some value is getting repeated in that tree, then that value is called as mode. Okay. So with this, we will try to solve this problem. So see this example, in this node 1, which is having the value 1, this is not having left child, but this is having the right child. So when you go towards the right child, you'll find this value 2. Okay. And when you find this value 2, you will, but then this value 2 has got left child. So it will again come to this. So here, if it comes, then, this is the left child. And after 1, it will come to this node, and then again it will come back to this node. Finally, it will be, reaching this node. So, when you traverse the tree in this in order fashion, you are traversing the nodes in the increasing order. So in order traversal, what we do, we first go to the leftmost node of the tree. And as we all know, in a binary search tree, the leftmost node is the smallest value, and the rightmost node of the binary search tree is the largest value. And in between these two smallest and largest, all other nodes lie. And when we do the in-order traversal starting from the leftmost, because the first call to in an in-order traversal is to go to the left, go left, go left, go left. So it keeps on going to the left. And every time when it, the call is there, a new, a new stack entry is there on the call stack, and we reach a new left child. So we keep on going to the left, and when we go to the left, we find the smallest, because all the smaller values of a node are towards its left, and all the larger values are towards its right. So if we travel this tree in an in-order fashion, and after traveling, while in the course of traveling, we, in between the traversal of the left child and right child, we do our logic of finding whether the previous, so we have to maintain the state. And to maintain the state, either we can, pass the parameters in the function call, or we can use, the instance variables. We can define some values in here, in between these lines, let's say here. So we can put some values over here. So like this, okay? So once we do this, these values will be used. These values will be used to maintain the state. And as we all know that instance variables are, they act as a repository in between multiple function calls. So we will write the code, and I'll explain these points, while writing and after writing the code as well. So, and during that in-order traversal, we'll be able to make out that which value is occurring multiple times, and we can associate a count and max count value to figure out, which node is occurring, which value, which mode is, which uh, value is getting repeated most of the time. So as since we have agreed, so we will do this in order, and then we'll pass the root. And see, the return type of this is an int, okay? But beforehand, we don't know what is going to be, how many elements could this mode can have. It can have either one element. See, here also it is, mentioned mode or modes. So anything, more than one element could be a possibility. More than two, three, any number of elements could be a possibility. The test case could be designed in such a way that we don't know beforehand that how many, elements could be there in that tree which are having the same value. So when we don't know, it's better to use dynamic, arrays, and array list is one such container which we can use. And, we can use that. And after, at the time of returning, when let's say the list is this, at the time of returning, we can just convert this to, map to end. Okay, like this. So this is going to convert our list to an array, but this list has to be declared somewhere. And I propose to, make all these things as instance variable. Why instance variable? Because we all know that in between multiple calls of a method of a function, the instance variable acts as a repository, and we can have the state of, um, state saved in these instance variables. So what I mean by this, I'll explain with this example, private int count. So count will be, as an instance variable, private int max count. This will also be a, instance variable, private integer. Why I'm declaring integer? This wrapper class, because I want to use null, and null signifies that this value is not yet set. Okay. If I use int, then I have to choose values from, the range of the int, and that could be one of the values of the tree node, and it puts us in a risk. That's why I'm using this integer, because null is for sure not going to be the value of any val in the node. Now, private list of integer. So list is of wrapper class type integer. Its name is list. This is what we are going to use over here. List is equal to new array list, like this. Then we'll do private void in order. So I'm not returning anything. Why? Because the side effect, whatever changes we are doing, it will be saved in these values, so we don't need to return anything. And this list is an object, so this is there on the heap, and we can easily access, whatever changes we are doing inside this in order function, so that can easily be accessed from this function as well. So no need to pass this function from this to different methods. So with this, we will, now we will write the logic for in order. So if root is equal to null, return nothing. Okay. If, or we can just say in order root dot left, like this. And then what we can do, then we will check if prev is equal to null, or prev is equal to null, or prev is not equal to root dot val. So this is, either we are, hitting the node of the tree first time. So at that time, this initial value of prev will be null. So both of the time we are going to initialize this count is equal to 1. Okay. So when the first time we are meeting, when we are encountering any node, that node value has to be 1. Also, when we are coming from a previous traversal to a new traversal and that previous root value was different from the current root value, we need to reset the count again. Okay. Because we want a succession of values which are same. And to find the succession of values, we have to, have a previous content of the previous root val is should be equal to the current root val. And previous is having this previous root val. Okay. So else is, else we just increment our count because previous root val is equal to the current root val and previous is not equal to null. Okay. And then we will check if max count is less than count. Okay. Then in that case, we will make max count is equal to count. Perfect. List. So if list is empty, then we need not do anything. But if it is not empty, then we have to, write one logic here that we need to clear that list. And after clearing this list, we need to, what do we mean by clearing this list? The meaning is that once we are clearing the list, if we are clearing the list, then we are making all other previous occupant of the list to be removed. And since we have found a new contender for that mode, we are going to add that new contender because this new root val is occurring more number of times than any other value. So we are adding that root val. Else what we are doing, else there is a chance that the two previous count and this max count, they are both same. If they are both same, then what we are going to do? Then we are going to add list.add root val. So previous value will also be there and the new value will also be there. But after this, we need to do one more thing. We need to, before we go to the next, next call of this in order, we have to set this current value to the previous. So current value of root to the previous so that, next in the next call, we are able to match it. So in order, then again, we'll pass the root dot right like this. And I think with this, we are done. So let me run this code and see how it's performing. Perfect. Perfect. So with this, we have come to an end of this, problem. Let me know if you have any doubt. So I would again like to, belabor a few points about this solution. All these, there are a lot many instance variables. These are used to save the state in between different calls of this in order. So see, count, its value is changing and we are using this instance variable. Max count value also is changing and we are using this. So list content is growing and shrinking all the time and we are using this instance variable. Prev value is also getting changed and we are using this instance variable. So this is one very important object-oriented analysis design principle that, whenever several methods of a class have to, are performing some tasks, some common task, and they need to interact. So they save their state um, in the instance variable, and we can use those instance variable. Otherwise, if you are not using this instance variable, then we have to pass these values individually in between as argument to the function calls, and that is kind of cumbersome and prone to errors. So it's better just to write them once And so these act like as a shared variable in between all the functions. And see, in this example, find node is just calling in order, but in order is getting recursively called several times. So in order, in between different invocation of in order, also these instance variables are acting as a shared state, shared, repository kind of thing. And with this, I would, I think it's easy. Only this these two lines are part of any in order traversal. So is this line. Only thing is happening which is new is in between these lines. So what we are doing, that from the previous iteration, uh, what is the value, whatever is previous is containing the previous iteration's root value, and current root value we can get with the root.val call. So this is holding the current value, and previous is holding the previous uh, invocation of previous invocation, what was the root val in that previous invocation, and we are checking whether it is equal or not equal. So if it is not equal, we are resetting this count. Otherwise, if it is equal, then we are incrementing that count. Obviously, that's what we have to do. If several successive values in order traversal, because in order traversal, the outcome of in order traversal will be a sorted uh, value of numbers. And if several successive values are coming, they are same, they'll be coming up against, they'll be lying by the side of each other, okay, adjacent to each other. So we have to increment that count, when subsequent elements are, the same, then we have to increment this count. And once we have incremented this count, then it makes sense that we need to we compare this with the max count. And after comparing this max count, we check that if count value is more than max count, then we upgrade the max count. And for sure, now we know that this count is greater than the previous max count. So whatever is the content of the list is of no, it's not relevant to us now, and we are forced to clear it. And we are adding new value into that list. And after doing this, what we are going to do, we are, this is one scenario. Other scenario is that count is equal to max count. In that scenario, we are not going to clearing, we are not going to emptying the content of list. We are just adding the new value to the previous content of the list. And that's what we are doing at line number 37. After finishing all this, before making the next call at line number 40, what we are going to do, we are doing that, we are setting the value of prev uh, into the value prev. We are in the variable prev, we are setting the value of root.val, so that for the next call we have correct root val, correct value in the prev. So this is what is happening in this function. If there is any doubt, please post it in the comments, and I'll be uh, definitely I'll try to answer those doubts. So with this, thanks a lot. Done.